Hello, Namaskar. This is P.V. Sudarshan from the Department of Chemistry, St. Joseph Pre-University College, Bangalore. Today we'll be discussing about general principles and processes of isolation of elements. I hope again and again rewinding chemistry, you would have studied this so many times that you are fed up of reading the processes again. But believe me, in this, what is that you are going to learn is the ores, their combinations, alloys, processes, refining techniques. These are the finer points again we shall be analyzing and then be doing it again and again. I am not here to give you the definition and then the answer for it, but as we look into every question, we shall answer the question according to its merit. We'll move on to the first question. The composition of azurite ore is azurite. What is an azurite? Azurite is an ore of copper. Azurite is an ore of copper. As you look in, you have here all our ores of copper, option A, option B, option C and option D. When you look into this azurite, the chemical formula or chemical composition of azurite happens to be CuCO3 dot CuOH twice, repeated 2 times, that is azurite. I'd like to confirm it once again. You have option B and option C. Option B, you have CuCO3 dot CuOH twice. It happens to be malachite. 2 times of malachite happens to be azurite. Hope you got it. What am I trying to tell you from this topic is, as you learn through the alloys, as you learn through the ores, remember the combinations by which they are being framed. It will be helpful for you to at least attempt a question in metallurgy. In this, let me conclude. Cu2s, copper glance. CuCO3 dot CuOH twice is malachite. Twice CuCO3 dot CuOH twice is azurite. CuFeS2 is said to be chalcopyrite or copper pyrite. The answer relevant for this question is azurite, which is option C. We'll move on to the next question. Which form of iron has the maximum carbon content? The learning point in this question is, greater the percentage of carbon, more impure is the sample. As we look into, I have stainless steel, mild steel, pig iron, wrought iron. Underline my words here. The purest form of iron is that which has got very less or nil percentage of carbon. Wrought iron has got to an extent of 0.25 percentage of carbon. Next, I have pig iron. Pig iron has carbon content to an extent of 4%. Next, cast iron has got carbon to an extent of 3%. Steel has a carbon content of maximum 1.5%. If I happen to put this in order, the maximum percentage of carbon lies in pig iron 4%, cast iron 3%, steel 1.5%, wrought iron 0.25%. Therefore, I am writing 2 underlining statements for you. The purest form of iron is wrought iron containing 0.25% of carbon, while that impure form of iron containing maximum percentage of carbon is pig iron, which is 4%. Coming back to my question, which form of iron has a maximum carbon content? In this, the right option is pig iron, which is 4% of carbon content. Hope you have understood this. if you have understood the second question, I think third one you should be able to answer as I scroll down. Arrange the following in the increasing order of carbon content. As I said, the underlining statement, lower the percentage of carbon, more purer is the sample. Greater the percentage of carbon, impurities exist. Example, in this I said pig iron, maximum percentage of carbon. Wrought iron, least percentage of carbon. Therefore, here depending on the carbon content, I understand that wrought iron and pig iron are at the extreme ends. Therefore, if I happen to read out wrought iron 0.25%, cast iron 3%, steel 1.5% doesn't match according to the symbols here. Coming back to the second option, wrought iron 0.25%, less than steel 1.5%, less than cast iron 3%, matches to the situation and matches to the question. Therefore, my right option is option B, wrought iron, less than steel, less than cast iron. Dear students, from these two questions, I would like you all to read the topics of ores, iron content, carbon content, percentages of each, combinations of the ores and then alloys. It will definitely help you. To give a recap of, I gave a composition of azurite ore is so and so. If I tend to go to the composition of aluminium ores, you have alumina Al2O3, diaspore Al2O3.H2O, bauxite Al2O3.2H2O, kaolinite Al2O3.2H2O followed by 2 SiO2. If you happen to read like this, I think you will be successful in attempting these questions that appear in metallurgy. Dear students, our next question is, during roasting, given the following options, let's understand first what exactly roasting is. The first stage in the metallurgical processes is concentration of the ore. Concentration of the ore refers to removal of impurities. After concentration of the ore, converting the ore into its respective oxide requires roasting or calcination. When do I choose roasting and when do I choose calcination? Roasting is a process of heating the ore to a high temperature in the presence of air or oxygen. Let me tell once again, heating the ore to a high temperature in the presence of air or oxygen. Then when do I choose this roasting? Roasting is basically chosen for sulfide ores. Example, zinc sulfide after concentration, zinc sulfide is roasted to get zinc oxide. Further gets reduced to zinc using a reducing agent. If I am doing calcination, carbonate ores are calcined. When I say calcination, it is heating the ore to a high temperature in the absence of air or oxygen. What is the underlying criteria between roasting and calcination is, roasting is for sulfide ores, calcination is basically for carbonate ores. During roasting, sulfur dioxide gas is liberated, while in calcination, carbon dioxide gas is liberated. So, keeping these key notes, let us analyze. During roasting, the sulfide ore gets converted to oxide ore. The carbonate ore gets converted to oxide ore. The oxide ore gets converted to metal. The impurities present in ore is removed. So, all the options if you happen to analyze and discuss, the sulfide ore gets converted to oxide ore happens to be the right option. Option A is correct. Option B, if it is the answer, then my question should have been during calcination. Option C, if this is the answer, the oxide ore gets converted to metal, then this is a method of reduction, where a metal oxide is converted into a metal. And finally, impurities present in ore is removed. This is concentration of the ore. So, all the 4 points we have discussed.